Good evening, algebra students, and welcome to another lesson. We are still in section 8-5, but now we're in 8-5 day 2, and we are still factoring x squared plus bx plus c, but we want to practice with a little more examples with negatives, because negatives can definitely throw us off a little bit. So what I'd like for you to be able to do is to factor a trinomial into two binomials regardless of where negatives are in the expression. So first of all, let's just review some basic concepts. It says when the last term is negative, one of the factors is positive and the other is negative. So remember, we're looking for multiples that multiply to the last but add to the middle. So if two numbers are going to multiply to a negative number, then we need a positive and a negative. And we're going to list factors with both options to see which one adds to the correct middle number. So for example, if we have, let's say, negative 12. Well, when we have negative 12, negative 1 times 12 would add to 11, while 1 times negative 12 would add to negative 11. So we want to make sure we list all the options in order to make sure that we are adding these things up correctly. So we could keep going with this with 3 and 4. I'll show you what that looks like. Negative 3 times 4. When we add those up, that would get us positive 1, or positive 3 times negative 4 would get us negative 1. Okay, so that's why we need to make sure we're listing multiple options so we know which pairing we need to use. So let's jump in with this first example. There is a bit of a typo, so this first example, this middle term should actually say 5. So we're looking for x squared plus 5x minus 36, and we're looking for multiples of negative 36. So I'm going to come up here to the side and look for things that multiply to negative 36. So for example, negative 1 times 36, or negative 2 times 18, or negative 3 times 12, or let's see here, negative 9 times 4. Now notice when I have negative 9 and 4, if I were to add these up, these would add to positive 5. So if I have 9 and negative 4, these add to negative 5. So if I want them to add to positive 5, then I would need 9 and negative 4. So this is my pair that I'm going to use. And I'm going to do this strategy the same exact way I did before. So this 5x is going to be broken down into 9x minus 4x, and then I'm carrying down my minus 36 and my positive x squared. Then I want to look at this as the front half and the second half. So the front half is x squared plus 9, and the back half is negative 4x minus 36. Now look for the GCF in the first two terms. What's the largest thing I can factor out of x squared and 9x? The largest thing I can factor out is an x. And what do I have left over for the underlined yellow part once I factor that x out? I'm going to have x plus 9 remaining. After that, I'm looking for what I can factor out of the second half. Well, notice how both of these are negative, so I know I need to factor out a negative number. And what's the biggest number I can divide out of negative 4 and negative 36? Well, I can divide negative 4 out. So now what do I have left over when I divide negative 4 out? I have x plus 9. At this point, I have this x plus 9 that's matching. So I'm going to be able to factor that out of the front and back. So the front part of my expression and the back part of my expression has that x plus 9 in common. So I'm going to factor x plus 9 out. And now what do I have left over? I have x minus 4, so that's my next set of parentheses. And there's your solution. All right, let's do that again in example B. So I'm looking for multiples of negative 21 that add to negative 4. So let's just list some multiples of negative 21. For example, 1 times negative 21, or 3 times negative 7. Here we've found our multiple already. Make sure the negative is on the 7 and not the 3, because if I had negative 3 times 7, these add to positive 4, while these two add to negative 4. So that's why I want to use positive 3, negative 7. And I'm going to split up that middle term. I'm allowed to split up that middle term because I'm not changing the value. When I say positive 3x minus 7x, I'm not changing the value because 3x minus 7x is negative 4x. All right, so now I'm doing what we've done before, where we look at the front half and then we look at the back half. What is the largest thing I can factor out of the yellow front half? Well, I can factor out an x. So I'm going to write that x down. And what do you have remaining once you factor that x out? So x squared with an x taken away still has x. 3x with an x taken away still has positive 3. Now let's do this back part. Negative 7x minus 21. Notice how I have a negative and a negative, so I want to divide that negative out. And now 7 and 21, what can I divide out of both of those? I can divide a 7 out of both of those. So now when I take negative 7 out of negative 7x, I still have x remaining. And when I divide negative 7 out of negative 21, I still have positive 3 remaining. We want to make sure that our parentheses do in fact match. That needs to be the case, otherwise we won't be able to keep factoring. So we do have matching parentheses, so we're going to factor out the parentheses with x plus 3. And then what do we have remaining after that? Well, I haven't done anything with this x up front, and I haven't done anything with this minus 7 back here. So it's just going to be x minus 7 for my second term, or my second binomial, I should say. And there's your solution. All right, in example C, I'm still doing the same strategy. That last term is a negative number. That 8 is a negative 8. So I want to find values that multiply to negative 8, but also add to 2. So some things that multiply to negative 8 are positive 1 and negative 8, or negative 1 and positive 8, or positive 2 and negative 4. Or negative 2 and positive 4. Notice how this negative 2, positive 4 is going to add to a positive 2 right here. I don't want to use this pair because this pair up here is going to add to a negative 2, but I want this 2 to be positive. So this 2x is going to be rewritten as negative 2x plus 4x, and then I still carry down my minus 8 and my x squared. Okay. Now, I'm going to divide this up into the front half and the back half. And what is the GCF of x squared minus 2x? Or what is the largest value I can pull out of both of them? Notice how they both have an x in common. If I'm just ignoring that part right now. What does x squared minus 2x have in common? They have an x in common, so I'm going to pull that x out. Now, what do I have remaining after I pull an x out of both of those terms? So x squared with an x pulled out, I still have an x. Negative 2x with an x pulled out, I still have minus 2. Now that I've taken care of the yellow part, now I'm looking at the pink part. I'm going to pull out a positive 4 because that's the GCF of that back part, and I have x minus 2 remaining. Now, my final step for this form of factoring is to just rewrite. So my parentheses are matching, which is exactly what I needed. So I'm going to have x minus 2 times x plus 4, and we are good to go. Don't forget that if you change the order, that's okay. So if you wrote x plus 4 times x minus 2, that's still the same answer. We're going to do example D, and then we'll do the remainder in class later on. Okay, so we're looking for multiples of negative 27 that add to positive 6. So we've got negative 27 here. And what are some things that multiply to negative 27? For example, we have negative 1 and 27. or 3 and 9. Sorry, not positive, negative 3 and 9. There we go. And as you can see, those two are going to add to positive 6. Negative 3 and positive 9. So we found our pairing. Rewrite your middle term as negative 3x plus 9x. Carry down your minus 27 and your positive x squared. Now, we're dividing this into 2 halves. For the first half, underlined in yellow, what does x squared minus 3x have in common? They have an x in common. And when I factor that out, what do I have remaining? So x squared with an x factored out, I still have an x remaining, so that's going in the parentheses. And then negative 3x with an x factored out, I still have a negative 3 remaining. Do that same process with this back part now. I'm going to pull out a positive 9 because 9 can be divided into both of these terms. And when I do that, I get x minus 3 remaining. All right, my final step is to just rewrite. So my parentheses match. I'm going to pull out that common factor, which is the parentheses. I'm literally factoring out this expression from the front part and the back part. But when I factor something out, I always ask myself, what did I leave behind? So if I factor out that x minus 3, what did I not factor out yet? Well, I didn't factor out that x, and I didn't factor out that plus 9. And there's our solution. Don't forget to check your work. And if you need to check your work, if you're not feeling super confident, you can always FOIL your problems back out to make sure that they multiply back to your original expression. All right, we will do the next 2 problems later on, or you can attempt them on your own. But until then, have a great night, and I'll see you later. Bye.